When dealing with quadratics, so far we've learned how to model them. So modeling quadratics is the graph, okay, which is the parabola. You've known now all the key characteristics. Right? So we've talked about where it's increasing, where it's decreasing. We've talked whether it open upward or downward. We talked about the vertex, the axis of symmetry, the x-intercepts, sorry, I wanted to put the S in parentheses because sometimes there's one, there's two, and there's none. And we talked about the y-intercept. We talk about plotting points, so you can have any point on the graph and then you name it. And we talked about image points, which are the points that reflect across the graph. Okay, so these are things we've already talked about. We're gonna move forward now to solving. Solving quadratics. So the solutions are also referred to as the zeros of the graph. They're also the x-intercepts. So sometimes the question will say find the zeros. When it says this, it is talking about the x-intercepts. Sometimes it's going to say find the solution. And they're talking about the x-intercepts. It might even say solve the quadratic. And again, it's talking about the x-intercepts. And I want you to know this because no matter what the worksheet and or computer program says, they all mean the x-intercepts. So we're going to review again what the x-intercepts are. So here's my quadrant plane. If you have a quadratic that never touches the x-axis, right, this would have no solutions. Okay? In reality, the solutions are going to be imaginary, which are a real thing in math. We'll get there. If you have a quadratic, we're going to pretend that touched there, right? This has one solution. So this would have one x-intercept. Then you're going to have something that looks like this. This has two solutions. Okay? So what I'm going to do for today is stop here, and I will give you some notes after, but I want to make sure that I do this slowly.